Here's every problem to quiz 1 worked out so you could see how I came up with the solutions. So for number 1, we have an equation that does have fractions. If you look at all 3 denominators, we have 6, 4, and 3. So what can they all go into? The LCD here would be 12. So I want to multiply everything here by 12 or 12 over 1. And because that 2 plus x is a binomial, I'm going to put that in parentheses. Same thing over here with the 3x minus 1. The 1 isn't a fraction, but it still needs to get multiplied by 12, and then 12 over 1 times this last fraction. So what's going to happen now is 6. Because I chose 12, all 3 of these denominators go into 12, so we're going to simplify the fractions here. So 6 goes in itself once, into 12 twice. So what are we left with? 2 times the quantity 2 plus x, minus 4 goes in itself once, 12 3 times, so now we're left with 3 times the quantity 3x minus 1. Over here we'll get 12, and then 3 goes into 12 4 times, so this will become a 1, this will become a 4, and then we'll get 12 minus 4 times the quantity 2x minus 5. So now we want to distribute, and then combine any like terms on either side here. So we're going to have a 4 plus 2x minus a 9x, but then be careful here, we're going to get a plus 3 equals 12 minus 8x, and then we'll have a plus 20. So combining like terms over here, we're going to have a 7 minus a 7x. So the 4 plus 3 gave me that first 7, 2x minus 9x is a minus 7x. Over here we'll get 32, the 12 plus the 20, they're both positive, minus 8x. I'm going to go ahead and add 8x to both sides. So this will give me a 7 plus x equals 32. And then I'm going to subtract 7 from 32, so that will give me 25. For number 2, we're simplifying radical 50. So I first want to factor, and one of the factors has to be a perfect square, so we're going to use 25 times 2. So 25 is the perfect square. I'm going to take the square root of that, so that's 5, and then I have radical 2. So whatever the perfect square is, that's going to come out when we take the square root. So we get 5 radical 2. All right, for number 3, this is a literal equation. We want to solve for x. So if you notice, we have 2 terms that have an x with it. So I want to get all of those x terms to the same side. So I'm going to start, and we can move them to either side. I'm going to move the cx over to the left by subtracting it. Then I want to move the by to the other side by subtracting that. So I'll get ax minus cx is equal to d minus by. So how do I go from seeing 2 terms with an x down to 1? Well, I factor out an x, so that's going to leave me with an a minus c. And then that's what I'm going to divide both sides by. So x is going to equal d minus by over a minus c. All right, for number 4, because there's negatives underneath, I can't just go ahead and multiply these 2 numbers together to get rid of the negatives. I first need to take the square root of -1. So, and also the numbers themselves are perfect squares. So really the square root of -25 becomes a 5i. The square root of -4 becomes a 2i. So now this gives me 10i squared. And because I squared is a -1, this now turns into a -10. All right, 5, we're simplifying the power of I. So I to the 44th. We're using the properties of exponents here. So 44 is the closest number to 47 that 4 goes into, and then I would have I cubed left over. So since 4 goes into 44, this whole I to the 44th just becomes a 1. And then I cubed is a -I. So 1 times -I is just -I. Now for 6, I wanted you to solve by factoring. If we look, there is no GCF, so we're just going to try 2 sets of parentheses. Now it's very important to keep this still equal to 0. We can't lose the fact that it's an equation. The only way to factor 3x squared is 3x times x. And then we have some choices for this 4 at the end here. We could try 2 and 2. We could do 4 and 1, 1 and 4. I'm going to try 2 and 2. and see if that works. So on the outside, I'm going to get 6x, and on the inside, I'm going to get a 2x, and that will help me get to a 4x. I just have to figure out the signs. Because this last number has a minus sign in front of it, my signs need to be different. And this sign right here tells me the larger of the two. So when I say the larger of the two, I mean the 2x and the 6x. In order to get a negative 4x, the 6x needs to be negative and the 2x needs to be positive. So I'm going to put my minus here and then the plus here. Now I'm going to set both of these equal to 0. So 3x plus 2 is equal to 0, or x minus 2 is equal to 0. And then I'll solve. So here I'll get 3x equals negative 2, so x would equal negative 2/3, or over here x is going to equal 2. All right, for number 7, we've definitely practiced plenty of these in class. We see two complex numbers here, but we can't leave an I in our denominator, so because they're binomials, put them in parentheses. I need to multiply by the conjugate of the denominator, so that becomes a 2 plus 5i. And then continuing on, first I'm going to have 4 times 2, which is 8. 4 times 5i is 20i. Then we'll have 3i times 2, so that's 6i. And then 3i times 5i, so that's plus 15i squared. And our denominator, 2 times 2 would give us 4. On the outside, we'll get a 10i. On the inside, we'll get a minus 10i, so those cancel. So now all I have to do is the last part here, so it's a minus 25i squared. So now up top, I'll get 8. I can combine the 20i plus 6i, so plus 26i. And then I squared turns the positive 15 to a minus 15. Over 4, this will become plus 25. I squared will turn the minus 25 into positive 25. So now I can combine 8 minus 15 is negative 7 plus 26i. And because I wanted you guys to write this in the form of a plus bi, we just individually put them over the 29. So that's what I was looking for with those directions. All right, and the last one we want to solve by completing the square. So in order to do that, I want to get all my x terms to one side. So I want to add the 8x here, and then I'll add the 3, so it looks like this. Then we need to leave some space because I want to make a perfect square trinomial here. So this is where we take half of 8, which is 4, and then we square it, and that's 16. So we're going to add a 16 to both sides. So now this perfect square trinomial can be factored into a quantity squared, and then we're going to get 19. And what's going to go in there is an x, and then it's plus because everything's positive here, more importantly because this one is. And then half of 8, or the square root of 16, the same number, is 4. So now we're going to take the square root of both sides. But be careful, when I take the square root of this, the right side of this number, I need plus or minus. So now I get x plus 4 equals plus or minus radical 19. And my last step is to subtract 4, but I'm going to write it first. So negative 4 plus or minus square root of 19.